I'm talking about, the title is How the Code of Practice for Retrofit and Other Tools Can Help Raise the Standards of Design Professionals. Now, it's a big question. I mean, very much Robert there was talking about when the specification has been reached, how does the builder deliver it on site? What I'm talking about is how the hell does that specification come together in the first place? Is it compliant and can you prove it afterwards? Do we deliver the results? It's a whole mix of things, probably leaning slightly on the retrofit side of things. But we're doing amazing things, but we've got relatively little time to do it in. So we're doing all the right things, but we really have to move so fast. CPD is just arriving with the builders. There's all sorts of questions, other design professionals, etc. Anyway, so TGG, a few things. I mean, I'm going to be hopefully jumping a little bit here, but hopefully it kind of makes sense. And it's highlighting some good things, it's highlighting some errors, it's highlighting some things we need to work on as an industry. TGD 11 says very little about retrofit, but it does tighten up on some values. I think they get some things right, I think they get other things wrong. There's traditionally been much more in the technical guidance about new build. It was supported by home bond and all those other things. Home bond, I would say, does need a serious lift at this stage. There's been some remarkable progress in understanding the complexities of energy efficiency in retrofit. So I would say in the last 3-4 years, there's been an amazing move, mostly in the UK. I'm part of that, and my team is part of that, I'm glad to say. And there's some work even going on for Dublin City Council, I'll talk to you about later on. I think you know this kind of pattern as well. I'm not going to go through the whole thing, but where we're going is really extraordinary. And the analogy that we're kind of getting out of the site boots and getting into the spacesuits is not actually as silly as it sounds. We are really moving we're moving to a position where Germany was 15 years ago, literally. We don't have the same kind of gilded craft culture. We don't have sufficient respect in some ways for what guys are doing on site. We don't have as long a tradition of science embedded in our architectural or design practice. And I think one of the key things we need to do is to embrace the scientific aspect of construction and understanding why are we doing what we're doing and what's the impact of that. Does it make sense? In terms of BERs, this is the current situation in 2014. We're being asked to get to A2. NZEB for new build, nearly zero energy buildings would be pretty much around the A2 mark, as I understand it. You can see the slightly different patterns for the for domestic and non-domestic. Obviously, G is quite heavy, but I mean, really, G is probably GHIJKL, and all of those are lopped into G, so suddenly G looks high. But what they're really asking us to do in terms of NZEB, and this is obviously new build perspective, is that curve will gradually lessen, and will actually, effectively the curve moves to here. So we have the majority of certainly our new build going forward in this area, and the existing stock becomes more and more energy efficient. So we're talking about new build here, we're talking about the energy efficiency of the retrofit of everything else. That's a lot to do. It's now 2014, 2020 is 6 years away. Kind of a glib comment maybe, and maybe it's a glib image up there as well, but I think they make the point, culture eats policy for breakfast. Culture is incredibly important. In some ways culture is a wonderful thing, in other ways culture is something you're fighting. It's all those things. Culture is what we do when we're not thinking. Building culture like our own, we're not used to measuring. We're not used to recording what we do, and we're certainly not used to discussing or talking about failures. Each person in this room probably knows of certain, even small or major construction failures that the client maybe never got to hear about, that was buried, that wasn't talked about. Unlike, let's say, the medical industry, we're not used to sharing, we're not used to talking, we're not used to hearing the stories that teach us how to design or build better the next time. I won't read the comments, but it makes the point. We're not used to actually understanding. We don't even want to go into the building we just built. We'd rather just leave it with them and move on. So how can we know that we've actually delivered the building we need to deliver? Now, this is an example from the UK in a study which is a few years old now, but is very good. Low carb for real. It's on the internet. Stamford Brook, it's a housing estate with about 700 dwellings, maybe somewhere near Warrington in the UK. 1/3 of the ownership was the National Trust. So the National Trust said, wait a second guys, we're going to make sure this is done properly, we're going to measure it, we're going to record what we've done, we're going to learn from it, we're going to talk to each other. And it was designed for a standard that was above the UK minimum standard at the time. So it was innovative. Yet there was a performance gap. So the performance gap is the difference between what was expected to be done and what actually was achieved. And what they actually say is that there's not just one performance gap, there's layerings. There's a performance gap in the design, there's a performance gap in the construction, there's a performance gap in the measuring. I mean, there's multiple layers, but as we ask to do more and more onerous things, those gaps really, really matter, and we have to start taking account of them. We have to understand what are we doing, not just what we intend to do, but what we've actually done, and how to change that. So if you look at this example here, this is what they intended to achieve, very simply, but they overshot it. The energy levels, so the energy efficiency is poorer, it's higher, which is equivalent to a standard 2 stages before. Now, another example in the low carb for real, so that's Stanford Brook. Another example, low carb for real, they were trying to achieve a higher standard a few years later, and it also came into this exercise where there was a no faults, no litigation approach. Let's just open the books, let's be honest, let's share information that we can. I think really we should repeat this kind of process in Ireland. If there's anyone in Department of the Environment or SEII today, I would love to see that they engage with this kind of process here. We need to understand what we're doing. In this case, again, they overshot, which again was equivalent to 2 standards before. But if we're going towards NZEB and we're doing things that are tremendously, extraordinarily impressive, we're really into the spacesuit, we're doing technologies that are relatively unfamiliar, people are really being stretched. What's the potential level of overshoot if we haven't integrated what the hell we're doing at the moment? And here's an example from that low carb for real study, where this is one particular building, the slab was already in place, so the design value, they just accepted it. For the sake of the study, they accepted that the design value was the same as the realised value. Go down to the walls. Because of the amount of timber, the thermal bridge, the repeat thermal bridges of the timber was greater than expected. The thermal performance, the overshot was 3.8 watts per Kelvin for the walls. For the roof, it was 1.5 watts per Kelvin. This is energy units per second, per degree temperature difference. So you can multiply by 20 if there's a 20 degree temperature difference, and per second of the day. So these things mount up quite a lot. For the windows, they got the wrong specification. They mixed up a centre of glass with the whole window U value. For the party wall, they didn't think there was any energy loss through the cavity wall, party wall, which is quite common in the UK, less common here. And there was actually a significant energy loss. It was a 55.2% watts per Kelvin increase. Thermal bridging was poorer, and the net impact of this is that the building was emitting per second, per degree temperature difference between inside and outside, more than double, quite a bit more than double its intended use, its intended energy consumption. And that's measured. Now, these people also then sat down and talked about it, and they learned from each other. We need to understand these things in this kind of level of detail. So this and other examples, I would suggest, prove we need to put at least as much effort into funding research, into underperformance, changing the culture, measuring performance during and after construction, as into creating new standards, new targets, and we will certainly ensure that a high percentage of buildings actually meet the standards we're asking for, because we're not going to do this again. In terms of peak oil, in terms of all sorts of things, we need to do this right. We need to do it now, and we need to take that sensibly. So just an Irish example, kind of another kind of small Irish example. This is in the current home bond manual, and it's been in the last 7 home bond manuals. It is absolutely daft, and I'm sorry if there's somebody from home bond. It is daft. You can see the insulation wrapping up between these the joists that come across. Well, there'll be gaps there. The notion is that the heating from the house will heat the tank and stop freezing. That's the basic principle, and it's not a bad basic principle. But there's different ways of understanding that. And this comes from a day when we were asking for a U value in the roof of maybe 0.5, something like that. And the reality is this. This is what happens. The insulation falls away. No one's actually ever thought had that insulation staying there. There is no proprietary product to perform in that way on the market. And you get a piece of EPS that cracks, dropped on top of the tank. The insulation falls away, all the heat from that bedroom or wherever it is just goes straight into the attic, straight into outer space, and actually no one has benefited. It's slack guidance. It doesn't matter where it came from. It's in British standards as well, believe it or not, British documents. It's slack guidance. This is from the Code of Practice, Standard Recommendation 54, Code of Practice for Energy Efficient Retrofit of Irish Dwellings, which I think is a significant improvement. I'd still have some questions as to what is the product, how does that insulation stay there? How is this junction made? How is that junction made? What's the proprietary product? What's the interface between the pipes coming in? I mean, there's an awful lot of different questions there. But what about this? This is from Killarney Plastics. Yes, it's branded, it's a specific product. It comes from the factory pre-insulated. The lid is pre-insulated, it's a tight fit. There's no insulation on the bottom. It does need support, but you can deal with those issues. It's a product, it's there to go. Let's use that. So we need to kind of engage. We need those very simple, practical kind of learnings in terms of our specification, and help the builder deliver on site. One of the big comments that came from the Stamford Brook study by the University of Leeds, Metropolitan University of Leeds, was this one. I think this is really powerful. Underperformance, currently masked by cheap energy and oversized heating systems, will become more noticeable and less acceptable as energy prices rise and as target emission rates are reduced. So we're going into the funnel, and these things will become more obvious. The carbon emission limits of Code Level 3, this is a UK context, and beyond are likely to entail increased complexity, true, less redundancy, and faster rates of innovation, and unfamiliar low and zero carbon technologies. And again, this is all happening here. Unless the house building industry is able to develop systems and a culture capable of managing those challenges, underperformance is likely to increase in relative and possibly even absolute terms. That's really important. It's not enough just to say we're chasing targets that make somebody in Brussels happy. We've got to achieve this, and it has to be sensible, it has to be real, healthy. Specifically, the ability of all parts of the construction industry to learn and to retain learning will need to be transformed. So in a context where, and it's really laudable what Robert was saying earlier on about builders are just beginning to grasp the nettle of CPD, and, we can slap ourselves in the back at architects, we've been doing it, we've had, mandatory CPD, 5 years, 4 years? That's not very long, really. We really need to engage in a process of learning and being open and integrating and proving. Just an example of that, very simply, in the Passive House Plus website, which is, fantastic magazine, I'm sure many of you know it, they carried out a survey, a better than best practice survey for that in relation, I think, to this conference. And what was interesting, even in that kind of selected group, only 31% of construction professionals knew about zero energy requirements for all new buildings in 2020. So even within that selected group in the whole of industry, 58% of respondents hadn't yet designed or built dwellings to Part L 2011. And I have to tell you today, I've built the first Retrofit house in Ireland. I've built multiple award-winning whatevers. I've never built a new house under Part L because of the economy. So my ability to deliver, there's a question there. It's the economy has had impacts on us all, and we all have to do that learning. So there's challenges there. Training certainly helps. Training helps a lot. Training design professionals, my experience of that. This is a kind of some of the things that I'd be teaching them. I'd be going through with architects. I've taught about 600 architects over a 3 to 4 year period. Recently I taught a major Dublin practice, the offices in Cork, Dublin and London, I think, and I trained 3-day training courses for each group of 3. So it was 9 training days for one practice. They put that focus and effort into learning and what they needed to do. So talking to them about strategies for identifying the air barrier, strategies, where's your weather barrier, where's your wind barrier, where's your, how's your insulation continuity, getting that into the specification, educating the builder, helping the builder to achieve the results, creating a structure, a process. Here where we're talking about design and actually kind of trying to get across to maybe the lovey brigade of design architects who do beautiful things that maybe are not compliant at all. Maybe they are sometimes, maybe they're not other times. And getting across that this kind of extension, you may not actually be able to comply with it. If you want to go with quadruple glazing, well, that's fine. But that's where you may need to go with the 70% glazed extension to be compliant under certain parts of Part L. I mean, that's seriously onerous. Quadruple glazing is ridiculous, obviously. But to get across to people, you've got to change what you're doing. It's not just how the builder's building, it's the aesthetic you as an architect are choosing. How do you prove you're compliant? All those questions. Comments on the courses that I've given. I'm often told that they prefer to leave the scientific basis aside, just give us the solutions. It's the classic one, do you want to fish or do you want to learn how to fish? I'd really like to teach people how to fish. I think it's much more engaging, I think it's more transformative. But very often, even among the architects who are definitely better at sitting down and looking at a slideshow or engaging in a classroom context, they often just want to get the solution and move on. The variance in knowledge among attendees, that I've taught, very good architects, but the level of knowledge and understanding is huge. The practicing passive house designers and builders, they're clearly differentiated. The ones who'd integrated that knowledge, very different. Frequently told that the courses should be longer, but then but the architects rarely booked a course that was longer than a day. So you'd a real struggle. Like in the RAI, I'd be sitting down with the CPD manager saying, I need to create a course. I feel the course that we need to give is this length. And I'm being told, but they'll only sit down for this length. They'll only come in for that. Once they're in the door, they're saying, damn it, it's not long enough here. We need more of this. So there's a struggle because they've got many of them have small practices. They're trying to keep going. Professionals feel buffeted, like builders, I'm sure. They feel buffeted by constant onerous changes in legislation and standards. Many would prefer one large change than many smaller. I mean, we could, as a society, we could have, as an industry, just gone straight, let's say, to Passive House, as Brussels did, and just say, let's not do anything in between. Let's give the banks certainty. This is the quality, this is the standard, this is the specification. This is where we're going to. It's a huge jump, but we'll do it. Let's just do it and engage fully from a policy level down to the site. The architects who I'm training can feel unsupported by legislators, by institutes, and by educators of the new graduates, that the colleges aren't actually supporting what's going on, what needs to be done, and what actually is compliant. They complain that if they learn, maybe the engineer or the QS doesn't. All despair at the dysfunctional building control system, SI9 from March 2014. It's a further burden, and it isn't actually helpful. In some ways. I mean, it is helpful in some other ways. It is making people ask questions that they haven't asked before, but it is an unfair burden for what they need to do, and it isn't sufficiently supported. They know budget or builder often hinder quality, but they're less willing to see how their aesthetic and technical designs often do too. Changes have happened so quickly that they have difficulty in we have difficulty in persuading them that what we're teaching is not some sort of elective higher standard. It's actually minimum compliance. A roof, 0.16, 0.11, these sorts of values that need OU value that need to be achieved alongside a good thermal bridge values, alongside the proper ventilation, alongside, etc. It's no longer a case of do a bit better here and that gives you relaxation over there. You actually have to do better in all those areas. And like I said with the performance gap, you actually need to achieve it in reality. So in terms of support for the specifier and the certifier, where are we? We need signposts. This is an example that I gave in the UK last week at the Historic Scotland conference. So there's approved documents being mentioned and British standards, but we use a lot of those British standards. BS 5250, the Code of Practice for Control of Condensation of Buildings. This is now where an architect is sitting down saying, yes, I've got, let's say, a retrofit. It's a solid wall. I'm internally insulating. How do I deal with the condensation? Or how do I deal... BS 5250 is related to new build as well. It's a very good document, but it has a certain bias and there's things that are missing in it. How do I do this? You go from the approved document or the technical guidance document to the standard, that makes sense, the code of practice, which then leads you towards an evaluation method. Now maybe you're now going to a consultant or maybe you're doing it in-house, that there's different ways. But for instance, what was happening in 2002 was that there was a method for simulation allowed for. I wouldn't be happy with the top method, the hydrothermal performance, which is Glaser, a very basic method, but at least there was a process where that was pointed to. Now, I know this might sound arcane, but literally if you want to prove certification, if you want to go from a path saying, this is what we want to achieve, this is what we need to do, and this actually makes sense, and here I'm signing the document, you actually need these sorts of signposts. You need these documents that actually help you on the way. And you could say there was a convoluted path to allow you to use the appropriate standard, which was a newer standard for solid walls, let's say, being internally insulated. But what happened was they revised the documents in the middle, and they dropped out that connection. So suddenly this new standard, which isn't being implemented by the industry, is suddenly kind of floating out there, and with one reference, one sentence relating to it going across, suggesting that maybe it has a value. And then what had to happen was the Sustainable Traditional Buildings Alliance, the SGBA in the UK, they created Responsible Retrofit, which I'll talk about later, which is a very, very good knowledge gap study. They applied a first principles approach and proper evaluation. They created a document called the Moisture Document, which is now beginning to make the likes of Kingspan and British Gypsum and all sorts of big players take notice, certainly in the UK. They'll be following it here, saying, wait a second, this is actually a document that's been funded by DEC, the Department of Environment and Climate Change over there, and it's saying that this stuff's important. Maybe we need to change what we're doing. Maybe we need to evaluate, are we doing it right? There's the consultation document, and what we hope happens is we get that. Now, that might sound really silly, but that's kind of what you needs to go on at times to ensure that there's a proper process and standards and specification are correct and provable. In terms of evaluating, again, there's a retrofit focus here. How do we know we're doing the right thing for this building? Well, the first thing is actually visit it, open your eyes, and if possible, measure some things. And some studies like this, these tubes, they're about that size. They're called Carson tubes. They cost about probably €6 to €7, £5 each. And you literally pour water in. You can see there's a ring pattern as the water is being absorbed. This is just one little example of a very simple, practical technique that somebody visiting a site could determine the level of water absorption of the outside of a solid wall, because that will determine whether the internal insulation falls off laden with mould or it stays there and keeps you warm. So like very, very basic, very rooted, very simple, very real Carson tube testing. But obviously the site inspection, getting into the attic, doing all those sorts of things, understand it. It's not just about desktops. Now you're off to desktop evaluation. I was talking about the Glazer method earlier on. Very clever. Came from the 1950s. Goes back to earlier dew point methods from the 1920s in Germany and America. But relates to only a very specific type of building. And really, the building it relates to is either a freezer cabinet or maybe a cavity wall building largely, or a timber frame building with a very good well-ventilated rain screen. They're the kind of buildings that this method suits. But this is the standard method of evaluating condensation or mould risk in buildings in the UK and Ireland. And if you phone up a large manufacturer, they will give you this method and it'll take them 5 minutes to do it. Well, 10 minutes to do it. But it's not actually covered by the standard. It's the wrong method and it will give you the wrong answer. So the moisture document I mentioned earlier on is a way of actually helping people understand that and pointing them in the right direction. This sort of software here, that's just a screen grab of the WUFI software, which is the world-leading hydrothermal numerical simulation. It's the updated version of understanding this issue of mould and rot and moisture appropriateness in all sorts of things, from green roofs, unventilated flat roofs, solid walls, floors. It allows you to simulate failure. It allows you to simulate for every hour of the day, real climate files, real material characteristics, fully measured, all those sorts of different things. It's a very different beast and allows much more accurate and significant improvement in accuracy and much more value in terms of understanding what's going on. It doesn't do everything, but it's a long way. It's a big step forward. As Neil May says in the moisture document, all models are wrong, some are useful, and you have to understand that. You use these sorts of things, these tools, like the Carson tube. That's a tool. There we go, and so are these. But try and use the right tool and understand its limits, and make an educated assessment. Other kind of things, just kind of trying to understand. We were given a database of airtightness tests for real buildings, both new and existing, and trying to understand. There's two different measurement methods. You can look at the orange or the blue. You don't need to look at both of them. So maybe that's a bit complicated. But we're just kind of looking at where are these buildings and what's the kind of average airtightness level of a whole wide range of buildings, from maybe commercial buildings, banks, to houses, to apartments. And the average was, often hovering somewhere in this kind of territory of kind of relatively compact building, somewhere around 6 meters cubed per meter squared hour, which is a particular measure of airtightness. The government minimum at the moment is 7. It was 10 when it was introduced in 2008. So, maybe the standard that they're asking for is actually too slack. It is too slack. But if you look at different types of buildings, you get different types of results. That's interesting. Why is it interesting? What's going on there? What can we learn from that? I mean, we need to be engaging as the industry. Well, obviously not the guy who's on the site plastering, but the industry needs to be engaging with these sorts of questions. How do we build certain ways? Why do certain buildings underperform more than others? What does that have to do with geometry, with location, with, an example of a building in South Carlow, and it faced a very large field, a field of several hectares in length, and there was one small line of trees right in front. It had an air tightness that we measured of 10. I think it was 10. Actually, no, it might have been 8. But the client experienced it as an extremely leaky, hard-to-heat house. Now, what was the issue? 8 sounds even good by some people's metrics, not by mine. The problem was that it was facing a huge field. That house needed to be 3 or 2 or 3 or something for the airspeed, the very low laminar air that came down over that field and hit that line of detached houses. So the experience of the people inside, that's what matters. That they're the fuel, the heating bills, the thermal comfort. It didn't matter what the figure was. That building needed to be more airtight than another building in a sheltered part of Ireland. So final section, useful recent guidance and research from both sides of the Irish Sea. Arico, this is a study by a French company looking at ventilation that have a very strong presence in Ireland, and they were looking at a mid-terrace in Dublin. Really interesting study, looking at the issues of ventilation, different ventilation strategies, different levels of airtightness, different sizes of the room, for using validated software and coming up with some very important conclusions. Looking, for the whole range of ventilation that we use in Ireland. Really good study, really interesting guidance. There's the link for it. Responsible retrofit, I mentioned earlier on. This is more in the kind of area of research, I suppose, in that it's knowledge gap studies. And this is the problem. We're talking about NZEB, but this is the first ever study in the UK or Ireland, as far as I know, where someone has actually said, well, what is the knowledge that we have about existing buildings? What do we know about them? What do we know about them before they're installed? What do we know about them after? Who said it? What was the quality of the research? Was it peer reviewed? Can we trust it? What areas does it relate to building performance? All these sorts of questions. It hadn't been done before. Yet, the government in the green energy, the British government was pouring millions into the Green Deal, which they've now rowed back from an embarrassment. But they hadn't done this. And we were doing our own things, but we hadn't done this. We can now rely to some extent on their work, but we should have our own. This document, which I think is a valuable document, I'm not even going to go into. There might be some parts of it I'm not happy with, whatever, but at least it's now there. It exists. It's the code of practice for the energy efficient retrofit of Irish dwellings. That's a base. Yes, I think it could be improved, but we now have one and it's freely downloadable, which is also important. So many times standards aren't available at all, or they cost quite a lot. The STBA, again, did a fantastic job with this responsible retrofit guidance wheel. This is an interactive tool. You literally click on different squares the whole way around the tool, and it makes connections between the impacts this sort of measure here will have on other aspects of the performance of a building. Whether insulating at the eaves, well, that might have an impact on air tightness, or on ventilation of the roof void, etc. And then you can link on to standards, to documents, to all sorts of guidance that's, like I said, peer-reviewed, trustworthy, robust guidance on how to go further. So yes, it's a longer path, but it's really useful and it exists and it's attractive, it engages with people, it's fun to use it. The moisture document I mentioned earlier on from Neil May and Chris Sanders from STBA, remarkable that this body, this organisation, it's only been around about 3 years, has done things that are now changing policy in the UK and therefore will be changing it here. Again, a good document. One of my own documents is Historic Scotland Technical Paper 15, which will be out in November, and that was looking at Scottish stone walls, solid walls, and internal insulation, evaluation methods, and just building physics. So that's a document that will be out in November. I have to say it's been long awaited, but these things sometimes have a long history. And yeah, I think that'll be good. And then another one we're doing for Dublin City Council, because we're suckers for punishment, and we're honoured to be doing it. I mean, suckers for punishment doing two things at the one time, but it's great to be doing something for Dublin City Council. Energy efficiency in pre-1945 historic dwellings in Dublin City. And we're looking at 15 case studies. So we're actually looking from a heritage perspective with the formal heritage appraisal of ordinary Dublin dwellings, and then we're looking at how we can work with them in terms of energy efficiency. We're looking at minimum retrofits, we're looking at maximum retrofits, we're asking questions that homeowners might have. Why is the BER different to the energy bills I get in? What is this about a boiler? When does it work well or not? Am I getting the efficiency it says I'm getting? All sorts of questions. How do we use buildings differently now than we used to? All these sorts of questions, we're trying to address them as much as we can. But it's a study that clearly needs to be greatly expanded. As far as I know, it's the first time there'll be a measure of 6 U values of stone walls or solid walls in Dublin. First time that there'll have been hydrothermal evaluation of some of these sorts of issues about internal or external insulation for specific buildings in Dublin. This particular focus with a rigorous retrofit appraisal, heritage appraisal and an energy efficient appraisal, and the difficulty of working those together and acknowledging that complexity. So all these sorts of things we're trying to engage with, but we need lots more of this in order to understand and fully deliver on the targets that we're looking to achieve. Thank you.